This is for Year 12 Further Maths. We're going to remake the video because there was no audio on the other one. So I'll just go through each of the questions. Now, for question one, we want to determine attitude to compulsory voting and age are. Well, the attitude towards voting is support, no opinion, or do not support. You see that it's categorical because you can't measure. You can't measure as in you can't take averages of these three categories, okay? Whereas years is numerical. So the answer is the first one's categorical, the second one's numerical. For question two, the most appropriate way to graphically display information about age is to use well, we know that age is discrete numerical data, okay, and it follows like a continuum. So the best way to display that is through histogram, okay? The reason why we don't use a bar chart is because a bar chart displays categorical data, and you're just counting using, you're counting like the number of blue phones or yellow phones or something of the class, okay? Whereas histograms follow a progression and age, like you can have age brackets between 0 to 10, 11 to 20, etc., okay? 21 to 30. Question three. The variable number of people at a rock concert is well, number of people. You can count them. Remember, anything that's countable and it's not measured, because you don't measure the number of people, you just count the number of people, you can't have like 3.5 people or 3.75 people, unless we're talking about dead bodies here, but we're not going there. It must be discrete numerical data. Okay, so we know it's numerical. Is it discrete or is it continuous? Continuous would be something like that can be follow a wide range of different values in between values. So, for example, when you measure the amount of flour you use for a cake, you can have 233.358 grams, like something like that. Okay, so you have values in between. Whereas discrete values are only countable, so it's 1, 2, 3, 4, or 5, 6, whole numbers. Question four: the percentage of people in Sassafras who are aged 20, less than 20 years, is closest to the percentage. Now, can you see that you need to pay attention to the percentage column. I can see the percentage. This is already in percent. You're just counting less than 20 years. Less than 20 years would be around 19 plus, I'll say 15. So if you read the values, it's going up by one. So it's around 19 plus 15. So you should get 34. So 19 plus 15 would be 34. In 1986, 1459 people lived in Sassafras. The number of residents under 10 years of age, is here. We know that 19% is under 10 years of age, but we want the number of people. Out of these people, we want 90% of it. So 19% of 1459. So how do I do this on my CAS? So 19 divided by 100, because we want 90% of 1459. So remember the formula if you don't figure it. So it's 277 people. So it's D. 6, the center of the distribution lies between. Now, this is always tricky. How do I work out the center of histogram? This is how I do it. I work out how much each bar contributes. And we know that this will add up to 100%, right? Now, we've got 100 percentage points. The median would be 100 plus 1 divided by 2. So it will be the 50.5th position. How do I get the 55th position on a histogram? Simple. Instead of like counting one by one, you just count the bars and see what the total is if you progressively add the bars. So I know that if I go 19 plus, we'll just say that's 15, that's 34. That's not above 50.5. Okay, so we just go up slowly until we get to the first bar that goes above 50.5. So if I add 21 to that, I can see we've got 1, 2, 3, 4. It's the fourth bar where the 50.5th position lies. Okay, so I'll repeat that again. To get the median position, we know all the bars add up to 100. Okay, they could add up to something different. Okay, but in this case, it adds up to 100 because we know it's a percentage, right? All percentages add up to 100. So where is the 50.5%? You just add the bars, add the percentage until you first go above 50.5. Okay, or first reach 50.5, and it happens to be between 30 and 40. Okay, it's a bit tricky, but they do ask these in the exam, so you got to know this. Question 7. For this data, the modal income is, okay, this is a log scale. Okay, you can see it's 1, 2, 0, 1, 2, 3, 5, 6, 7. So the modal income is the most frequent. The most frequent is between 4 and 5. Now, obviously, it doesn't say 4 and 5 here because this is a log scale. We want actual income. So to get it into real numbers, you just go 10 to the power 4 and 10 to the power 5 to get to real dollar amounts. Okay, it happens to be 10,000 and 100,000. So C is the answer. Question 8, percentage of companies in this sample with annual income less than $1 million is, okay. Now, in order to read this graph, we want to convert this real number to a log number. So log base 10 of $1 million is 6. So we want percentage with less than 6. Okay, less than 6 is all the bars here. I've counted the frequency of each bar. So when you add them together, you should get 30. Okay, and the final bar takes up 3, so the total is 33. So out of 30 out of 33 countries, so 30 out of 33 times 100% gives you 91%, which is A. Question 9. The range of incomes that have a frequency of 2 is, okay, the frequency of 2 is, well, only this bar has a frequency of 2 as the count of 2. And we want the range of incomes. Remember, this is log scale, so you have to convert back to original. So 10 to the power 0 is 1 if you're doing a calculator, and 10 to the power 1 is 10. So between 1 and $10. So it's B. For the distribution displayed, the range is the largest value, 54, minus the smallest value, 31. 54 minus 21 is 23. So the answer is C. Question 11. For the distribution displayed, the center means median. You count how many data points are at, there are 15. To get the median position, you add 1 divided by 2. So 16 divided by 2 is 8. The F position, you count 1, 2, 3, 4, 5, 6, 7, 8. So it happens to be 35. For this data set, you enter in your calculator, you want to find the median value. Okay, so I'm going to do that. If I go on stats, I've already entered this in my calculator. So we look at list 1. So calc, one variable, list 1. I can see my median is 21212.5. Okay. The interquartile range is Q3 minus Q1. So 215 minus 210, that gives you 5. Okay, so the answer is A. Question 14. The following data set, the 5-number summary is, okay, I've typed it on my calculator again. So list 2, calc one variable, list 2. It's really important that if you have, now the reason why I did delete list 1 and re-enter the data in is because if I want to go back to it, I can on the test. Okay, it's always good to double check your work. Now, so I select list 2, okay, 5-number summary, so you go min, Q1, median, Q3, max. So the only option that has that there is A. Okay, same, it matches. The mean free sig fix is, okay, so again, you enter data, you got to be quite accurate and efficient with this. List 3, I put it there, calc one variable, list 3, and the mean is x bar, which is 11.3, and it says the mean value to free sig figs, remember sig figs, 1, 2, 3. Okay, you count from the left, first non-zero number you start counting, 1, 2, 3. So 11.4 rounded. Okay, so that was a test of your sig fig skills. Corrected to decimal places, value standard deviation is, okay, standard deviation, let's go back to it, is just Sx. I can click this, Sx is 0.46. Okay. Question 17, which would not be appropriate to determine the mean standard deviation of a group of people? Well, what's the difference between what's common between salary, file length, years of schooling, and number of hours? They're all numerical data. School type's not numerical data, so it doesn't make sense to take the mean of, a Catholic school and a government school, okay? Because they're just simply type of schools. Doesn't make sense, okay? You can only measure something that's measurable, okay? Question 18. It's reasonable to use the mean as a measure of center distribution. Um, it's only usable if if I have a negative skew here, so negative skew means long tail to the left, to the right, sorry, long tail to the right. It means that what happens is the mean gets pulled because of these high values. Okay, so it gets pulled to the right because of these high values. So your mean will be higher than your median. If I have a negative skew, the mean will get pulled this way because you get extreme values this way, the mean will get affected. Okay, so median will stay the same. So it'll only be useful for the mean if you have a symmetric distribution. Okay, you can't have symmetric distribution of outliers. So if this was a symmetric distribution of outliers here, so pretend there's outliers here, this skew or outliers will affect the mean. They'll pull it. Okay, so it's very sensitive. So you need an absolutely symmetric distribution for the mean to be appropriate. Okay, for question 19, you got a test mark 75, the mean is 68 and standard deviation 4. So whenever you have mean, standard deviations, you should, and standardized scores, you should automatically go, oh, I need to use the formula for, it could be Z-score. So Z-score is given by the actual minus the mean divided by standard deviation. So you get 1.75. Okay. So this is just in some interpretation. 1.75 on this normal curve is one standard deviation a bit more above the mean. Okay, so they're performing above. They're one of the high achievers. Okay, so it's because they're a bit more than one standard deviation above the average, the mean. Sorry. 20. The standardized score is this. So Z score is here. The mean mark is 68 and standard deviation is 4. The, the actual test score is mean plus brackets. I always like to put brackets around the negatives. Negative z-score times the standard deviation, and I get 66. Okay. Now, question 21. In a normal distribution, approximately 95% of the values lie between. Well, remember how you had a chart I gave you? Use that chart. Okay, 95% would be two standard deviations of the mean. Okay, so if you move two standard deviations right and two standard deviations left, you should get it should add up to 95%. Normal distribution, approximately 0.3% of the values lie between. Well, 0.3%, well, 0.3 means 0.15 plus 0.15, so you're more than three standard deviations away from the mean on both sides. Okay, so more than standard deviation below above the mean. Okay. In the normal distribution, approximately 2.5% of the values lie. Well, this the last two here and the last two here add up to 2.5. You can confirm yourself. So it's either above two standard deviations or below two standard deviations. Okay, so it's more than two standard deviations above the mean will work. Okay, it's either one of them, but it's not both. Because if you add both of them, they'll add up to 5%. In a normal distribution, approximately 32% of the values lie between. Well, 32% is 16 plus 16, so it'll be here. So it's two standard deviations above and one standard deviation above and one standard deviation below. If you add all these together, you should get 32%. Okay. Uh, so you're given the heights of athletes. It's normally distributed. Just a normal, just a bell curve or a normal distribution. Mean of 157, so I put 157 here, and a standard deviation 3. So I've added 3, 3, 3. I've subtracted 3, 3, 3. I get, usually you just do 3 above and 3 below to answer the question. So 148, between 148 and 166, 148, 166, that's between 3 standard deviations above and below, okay? So that should give you 99.7%. The number of athletes less than 151 is these two, so it adds up to 2.5%. We want the number, okay, number, not percentage. So 2.5% of 256 in total gives you 6. Okay. Extend out to questions. Just stem and leaf not. Remember, put the stem here, leaf there. Now, what students got really wrong was they didn't put 8 here. Okay. Please put an 8 even though it's empty. Okay. Right order the values from smallest to largest. Okay. Some people did a split stem leaf mod. That's fine. So meaning that you split the 5 into two halves, 6 into two halves, etc. But the reason why you need an 8 here is because to show that that's an outlier. Okay, so this is a positive skew because it's higher here and then gets low here to the tail here. It's a positive skew with an outlier. Now, if you didn't write the 8 and I penalize you, I still accept the positive skew as the answer. But if you had that but didn't write with an outlier, then you would have lost the mark. The modal interval, and that's a bit tricky. What's the most common interval? Well, it'll be between 54 and 59. Okay, interval is the most common. 2, 4, 2, 4, 6. Okay. Question D. Actually, let me check the modal interval. How many 50s do we have? 1, 2, 3, 4, 5, 6. 2, 4, 5. Okay, I'm missing a value there. There should be 6, so that should be a bit higher. So the modal interval is 54 to 59. Okay, I think I've made a mistake somewhere here. I'm missing a value. Okay, so just double check that. Determine the percentage of curriculars with strike rates above 60. Okay, so 61. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of how much? Instead of counting the whole thing, just look at the total. It says 15 days. So 9 and 15 times 100 gives you 60%. Question 2, you count the number of rats, salads, and pies. I got 10, 7, 13. Add them together, get 30. Now you go to turn to percentage. Okay, how do I turn the percentage? 10 divided by 30 times 100, I get 33.33. Now I ran to two decimal places. Some students wrote 33.33 with a dot on it. The dot just means it goes on forever, okay, which is true. So for the salads, it's 23.33, and for pies, it's 43.33. Now, if you round two decimal places and you wrote 100 here, you will have lost the mark because if you add them, it doesn't add to 100. Okay, and that's okay because there's a rounding error. Because when you round, sometimes you get errors when you total them up. Okay, but if you wrote, 33.33 with a dot on each of them, and wrote 100, that's fine. But this is mathematically not correct if you wrote 100 there. Construct the percentage frequency bar chart. Okay, so now I've drawn a really bad one here. By all means, do not copy what I've done, but what's important here is you label the axes. Okay, so we've got a mark for that. Draw an appropriate scale. You notice that none of them go above 50, so going up to 50 is fine when I'm in tens. And you should be a third of the way between the two lines because they're 33.33. So if you went to a bit above, too above, then I would have deducted a mark. So I was very harsh remarking that simply because, you know, we're going to be harsh in the same. So do it well, use a ruler, have gaps in between the bars. It's a bar chart, so it's not a histogram. Okay. There's a few students that graph the counts. Read the question. It says percentage frequency. It doesn't say count. Okay, really important. It doesn't say frequency. It says percentage frequency. Question 3. 5 number summaries here. Uh, Minimum Q1, Q2, Q3 max. Okay. So IQR's Q3 minus Q1. 20 minus. Okay. I don't know what I did here. Obviously wasn't thinking. So Q3 minus Q1, 16 minus 8 is 8. Okay. B, draw a 5 number summary. Now on the SAC we usually provide a scale, simply because we don't want students wasting time doing that. Okay, again, I did this freehand, so use a ruler, please, in the actual thing. So use a ruler on all your graphs. Make sure you're very accurate. We're assuming these aren't outliers, so we'll just go minimum, maximum, and then the rest. Okay. Complete the following statements. The middle 50% of students scored between, well, the middle, remember with a box plot, this is 25%, this is 25%, this is 25%, this is 25%. So the middle 50% will be between here and here, so 8 and 16. 75% of students, well, this is 25%, these are all 25%. You need to be above a certain level to get 75%, so you have to be above here, because that adds up to 75%. Okay. Okay, drinking coffee. No, I don't drink coffee, but for sake of question, we want to fill in the data so that you get a Q1 of 2, median of 3.5, and a Q3 of 4. Now, look at the gaps. How many gaps are 1, 2, 3, 4, 5, 6, 7, 8? So you've got 8 gaps to fill. If I go 8 plus 1 divided by 2, the median happens to be the 4.5th position. So it's 1, 2, 3, 4 and a half. So it's between here. So you want a median result of 3.5. Now, what average of two numbers give you 3.5? Well, 3 and 4 will be the obvious choice. With Q, okay, so this is the median. How do I get Q3? It's the middle of these four numbers, and the middle of these four numbers is between two numbers. So you want a Q3 of 4, so the average of 4 and 4 will be 4. So you satisfied the 4 requirement for the Q3. The average of the median of four numbers is here. You want a Q1 of 2, 2 and 2 would work, okay? Because the average of 2 and 2 is 2. And does it matter what you put here? No, you can put 5,000, 1 million there if you want to, okay? Those are just fillers, okay? What's more important is what you put here, 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 okay? But you need to put something there because you need to fill in all the gaps. Because I had a student that didn't put anything there, they didn't get the mark. Or they didn't get full marks. So hopefully that helps. Make sure you go through all the questions and double check your answers. Remember, what's if you did do that well in the test, that's fine. Okay, it's fine for now. But what I want everyone to do is study, study, study. Because at the end of the day, you need to know this content. You need to know it very well. And what you don't know, make sure you learn it. Make sure you come see me. Okay. I'm more than happy to just have a lunchtime session for you to explain a concept. You can go, Mr. Chan, I don't really get this. That's fine. Okay. So please correct all your mistakes. Don't just write down the answers. Actually understand why you got something wrong. Okay, that's the key to success. It's improving on any errors you have. Hopefully that helps.